You are going to do okay. You are going to do two experiments. One experiment is in the car. That is about the radio. Okay, you just don't use that FM radio. You just use a knob to control. Then you will come to know on the scale only. You can come to know from which frequency to which frequency. Like suppose I have a channel 88.8 megahertz. Okay, keep this in the mind. This will be useful to you. It was in communication, but this is removed from the syllabus. Our in any country, not only if you travel US or Canada or UK, any country, European country or any country, the radio is fixed. Any radio will be from 88 to 108 megahertz. This is the fixed frequency given to the radio stations. So the radio stations are only between this one. So what we have here in UAE, 88.8, 89.1 megahertz, not kilohertz. And for regional channels like Malayalam or Telugu or some other channels, they have given kilohertz. Is that clear? They have given KH. So that is why we have FM AM. This comes under FM. This comes under AM. FM is frequency modulation, AM for amplitude modulation. Understood? FM for frequency modulation, AM for amplitude modulation. So if you want to hear Malayalam channel or some regional channel, then you have to go to kilohertz. Otherwise, this is the internationally fixed values. Okay. So we have 101 channel, 102.6 channel, 105 point something like that. 106 is also like that. Okay. So many channels are there. But there is some space in between the every channel. Okay. Is that clear? This is the resonance frequency of every channel. But you can start from which point to which point you are able to hear the song. Not clearly. Maybe this song, for this one you will able to hear 88 point or you will start listening to the song from 89 and then 89.89. Okay, I don't know exactly. Okay, we will take for 88.8. So you may start listening the song from 88.5, and this is a resonance frequency up to what, 89. Maybe you will be hearing the song. Okay, the same song, but it is blurred. The voice is not clear. Okay, so you just do this experiment today. This is first experiment. What you will do. The second experiment is with the musical instruments, and you can play the TV for some time. Do you have the musical system at home? No. Not instrument, musical system also not a problem. If you have an instrument, it's okay. You have an instrument, no problem. Do you have a musical system like which? Yes.
No, sir.
Okay, you don't have a. Okay. Suppose you have a TV, right? Everyone.
Yes.
Yeah, you have it. You are having a TV. Just increase the volume and decrease the volume and see how it is. Like you will be having the bits. How the sound is increasing. How the sound is decreasing. Like you'll have one bit. Okay. Is that clear?
Yeah.
You can notice that also. You can apply not only to this sound, you can apply to something like for the colors also. Color frequencies are also there. That we need not require, but at higher levels we do that. Okay. So that was about, there's a small homework which I'm giving it to you. Try this one. If you have a musical instrument, still you can play with that and you can understand how the resonance frequency works. Okay. Now, so what we have discussed, we discussed the bandwidth, we discussed the sharpness of the resonance. What is the formula for the bandwidth? What is the formula for bandwidth? What is it? 2 delta omega. Bandwidth frequency is 2 delta omega 2 minus omega 1 is equal to 2 delta omega. And
isn't it omega 0 by 2 delta omega?
That is the sharpness of the resonance.
Okay, sir.
Bandwidth is omega 2 minus omega 1, which is equal to 2 delta omega. And measure of sharpness of the resonance is omega 0 by 2 delta omega. Okay. So how do we calculate that? So we have a formula. I'm not going too much into that one. So we have a value here. Omega 0 by 2 delta omega equal to what? Equal to omega 0 into L by R. This is the way we can find out. So how will you come to know what is the sharpness of the resonance? Then just substitute in the formula, you will get the answer. Okay. So what do we get now? Omega 0 by L. Omega 0 by L. What is this value? Omega 0 by L is known as quality factor. Omega 0 by L is said to be the quality factor. Q, capital Q. Omega 0 into L by R is known as the quality factor. So here, what can we write now? So That is known as quality factor capital Q. Okay. So that is equal to Q. Quality factor that is equal to Q. Okay. I'll not write this. Quality factor capital Q. Now, so now if you equate this here, so omega 0. Now, don't ask me why, sir, how did this come? Because there is a derivation which is not required for you. Okay, I don't want to waste your time in doing that derivation. Okay, clear? We can do that. We can get it how
Yes,
to.
sir.
I don't want to waste the time here. Okay. No, that this only quality factor is important. Definitions are important. See, resonance. First is resonance, then comes bandwidth, then comes sharpness of the resonance, then comes quality factor, then comes wattless current, power factor. Only these are important. Only definitions are important, formulas are important. Don't go too much into the derivation. Derivation means only the LCR series. But why did I then, you may ask me, sir, why did you teach then resistor, capacitor, inductor? Why did you waste our time? Because to understand LCR, you need to understand what is RLC behavior. Is that clear?
Yes, sir.
Yeah. So now, so omega 0 is equal to what now? Omega 0 by 2 delta omega. So omega 0 by 2 delta omega will become what? By 2 delta omega will be equal to what? Will be equal to Q now. Okay. Now, if I want to find out the bandwidth, how to find out the bandwidth now? 2 delta omega will become omega 0 by Q. If you want to find out the bandwidth, then you can just substitute the formula to get the bandwidth. Is it clear? Is this clear? So here we have one more value, that is larger the value of Q, larger the value of Q. They will ask this type of questions in one marker. Like we have questions A, B, C. So in that questions they will be asking this. Larger the value of Q. So what will happen? The smaller will be the bandwidth. Okay. Smaller is the bandwidth. Why? Because it is in denominator. This is in denominator. This is in numerator. This is denominator. Okay. So larger the value of Q, smaller is 2 delta omega. 2 delta omega, which is known as bandwidth. Okay, I'm writing bandwidth like this. Is that clear? Or smaller is the bandwidth, or we can say sharper is the resonance. Okay, sharper is the resonance. Sharper is the resonance. And generally, the branded one or the expensive musical systems like Philips, Philips is the company which was very good in the musical systems. First, I don't know now which is the system. So earlier the Philips was very good, in musical systems, because the resonance quality was very good. Means they have very fixed, very close frequencies. Like suppose 20 we have one frequency, 21 one we have frequency, 22 also we have. Now the systems are coming with 20, 20.5, 21, 22, like that. Very close. That means very sharp is the resonance. Is that clear?
Yes, sir.
Yeah. So next one is what? Omega 0. See, we also know that. What is that? Omega 0 square equal to what? 1 by LC. And we also find out omega 0 is the resonance frequency, 1 by under root of LC. So we know what is that value. So therefore, we will substitute that value here. What is in the place of omega 0? So what is omega 0? 1 by root LC. Or omega 0 square is equal to 1 by root LC. So, so Q will be equal to what? Quality factor Q is equal to 1 by omega 0 into CR or RC. See, once again, we have the quality factor formula. We have this formula also. Okay. The quality factor formula is what? Quality factor formula is omega 0 L by R. Okay. Omega 0 L by R is a quality factor formula. Okay. So Q. So what do we need now? Omega 0 can be written as what? Omega 0 is equal to omega here in this place. We can also write omega 0. We want Q now, L by R. But omega 0 is 1 by root LC. And also we can write, these are the formulas, okay, and also we can write this value is already there. So this is one more formula. Q is equal to 1 by omega 0 into CR. the quality factor. This is in terms of, see, this is in terms of this quality factor formula is in terms of inductor and resistor. This quality factor formula is in terms of capacitor and resistor. That's the difference. Is that clear? See, this,
Yes, sir.
this quality factor formula is in terms of inductor and resistor. This quality factor formula is Q is equal to 1 by omega 0 CR. Okay. This is one more formula for calculating the bandwidth. These are all the formulas 1, 2, 3. And this is also a formula. Omega 0 is equal to 1 by root LC. That's a resonance frequency formula. Is it clear? Is this clear?
Yes, sir.
Now, next one is what? If R is low, if R is low or L is large, okay, circuit is more selective. If R is low or L is large, inductor is large, circuit is more selective. Circuit is more selective. What is the meaning of more selective? Circuit is more selective is what? You know, if you see LG TV or Sony TV, have you seen the Sony TV, LG? There's a difference, okay, brands. There are many brands like Sony, Samsung, LG and all. There's a difference, okay. Like the sound in Sony maybe from 0 to 100. And the same sound, the volume you can control from 0 to 100. But in some TVs, it is only from 0 to 50. You got my point. The maximum sound is the decibels. We generally measure the sound in terms of decibels. Think that it is 100 decibels. What I am talking to you is somewhere around 50 decibels, 50 or 55 decibels. Okay. In the classroom, when the teacher is talking, it is somewhere around 65 decibels. If the teacher is screaming or shouting, then the decibels is around 70 decibels or 72 decibels. Are you understanding? If you are whispering, it is around 15 decibels. Got it? Sound, the intensity of sound is measured in decibels. Are you understanding my point? So when you are whispering,
Yes, sir.
when we are whispering, it is around 10 decibels. When you are talking, when I'm talking to you normally in the class, it is somewhere around 50 decibels. In the classroom, it is 65 decibels. If I am going screaming, it becomes 72 or 75 decibels. Okay, maximum allowed maximum allowed international level is around 100 decibels a maximum. Otherwise, no, people will create a sound system at home only. Like they can create parties with the TVs only. Yeah, is it not? See, he has a decibel meter also nicely. See, he's showing the decibel meter. So here, satisfied. Sorry, what I have to do? No. See here, what is it? Okay. See here. Here, see when I'm talking to you, see it is showing the decibel also. Are you noticing this one? Yeah.
Yes, sir.
This is the intensity of sound. This is the intensity. Okay, it is showing 60 or 75 decibel. You can see that one. Yeah. Got it?
This is the recorder, right? In the
No, this is not the
recorder.
recorder. This is a decibel. See here. This is the decibel. Did you notice? I am talking to you and it is changing the value. Did you notice that?
Yeah, yeah.
I'm talking to you and it is the intensity. We can measure the intensity of sound also. Like what they do, the police people in India or here, like what they do is they will say that when you, especially in India, whenever there is a marriage, there is a band and all. Okay, and the band is exceeding 150 decibels also. The allowed is only 100 or 120 something, not more than that. You are not supposed to use more than that. Otherwise, the police people will put fine. Got it? So that is why in the TV also maximum allowed is the maximum is around 100. Okay, suppose 100 decibels is the maximum by a TV. Example I'm giving. But suppose I bought a Sony TV. In that I have 100 divisions in that. Means for every 1 decibel, 1 bit is there. So I can control that. I can control with the remote. Got my point? Is that clear?
Yes, sir.
Yes, Dhruti, did you understand this one? Okay, now the same.
Yes, sir.
Yeah, so the same thing if you go to LG TV or you may go to Samsung TV, there may not be 100 digits or 100 like these lines. When you are controlling you can do it on the TV also. Like these lines will be there. And as you're increasing the volume, this will become green, something like that. So green or red or green, I don't know. Red or green. I haven't seen the TV from a long time. Okay. So So it becomes red or green like that. Okay. So what happens in Sony, if it is 100, maybe in LG it is only LG or Samsung it is only 50. Means what? In Sony they have taken 1 decibel one line like this. But in LG maybe they have taken for 2 decibels they have taken one line. You got it? Got my point? So that is how that is selectivity. That is the meaning of selectivity. Got it? That means if R is low or inductance is large, the circuit has more selectivity. Means the 100 bits, for 100 bits we have 100 lines. Whereas if it is low selectivity means we have only 50 lines. There are normal TV like local TVs, only 25 lines. Means 4 bits, 4 decibels, 1 bit, one time you will press the button. That's it. It's like that. Are you understanding this one, Abid?
Yes, sir.
Yeah. Yeah.
Yes, sir.
So that is how it works. Okay. This is about, selectivity. So this is all, you need to understand with the example only. You cannot understand the terms just like that. The quality factor, the selectivity, the sharpness of the resonance, or, the sharpness of the resonance, or the, or the bandwidth. Okay. Now, power of a power factor. We will discuss now power factor. Is it clear, all of you? No. Okay, I didn't take the picture. No, power in AC, the power factor. Okay, power factor. Power factor. Power factor is what we are writing here. We already have the formula. V is equal to Vm sin omega t. V is equal to Vm sin omega t, and I is equal to Im sin omega t plus phi. But what is phi again? Phi is equal to tan inverse of Xc minus XL by R. Okay, this is the value of the phi value. Now, what is the power now? The power value is Vi. P is equal to what? P is equal to Vi. This is the formula for power. There are 3 formulas. P is equal to Vi, equal to I square R, equal to V square by R. This is the formula for power. So I'm using this formula. P is equal to Vi. Now I'm going to substitute these 2 values. Okay, let it be 1, 2, and let this be 3. Now substitute 1, 2 in 3. Then what will happen? P is equal to what? Vm sin omega t into what is that? Im sin omega t plus phi. Okay, sin omega t plus phi. Now what I'm doing now? I'm just multiplying and dividing by 2. P is equal to what? P is equal to, I'm taking the constants also. Vm Im divided by 2 into 2 sin omega t plus phi into sin omega t plus phi sin omega t. So we have a formula here. What is the formula here? Cos C minus cos D minus cos C. Cos D minus cos C equal to what? 2 sin C plus D by 2. This is a trigonometrical formula, compound angle formula. This is compound angle formula. Compound angle formula. Okay. So we are applying the same thing. I have this thing with me, so I have to write in this way. So that C plus D by 2 equal to what? Omega t plus phi. And C minus D by 2 is what? Omega t. Now what I am doing? C plus D is equal to what? 2 times of omega t plus phi. And C minus D is equal to what? Omega t. So, so what will happen when we add it? This D and D will go away. 2C is equal to what? 2 omega t plus 2 phi plus omega t, which is equal to what? 2C is equal to 3 omega t plus 2 phi. Like that, we get C and D values. Okay, we get C and D values. So we got here what? cos d minus, so we get here cos phi. Here we get c value is equal to, here by solving this one, we get c value is equal to 2 omega t plus phi, 2 omega t plus phi, and d value is equal to how much? 5 by solving that. Okay. Did you understand this one? See, I started with V is equal to Vm sin omega t, I is equal to voltage and current, and this is the phi. This is the phase formula. We have power 3 formulas. We are using the one of them and substituting 1 and 2 in that formula. Then we get this one. Are you able to see the board properly, all of you?
Yes, sir.
Yes, sir. Can you explain from the compound angle formula?
Okay. See, once again from the beginning, this is the voltage formula. This is the current formula. This is the phase angle formula. There are 3 formulas for power which you studied in grade 10. I'm using one of them. I'm going to substitute 1 and 2 in 3. Then I got this one. Okay. Then I took the constants outside and multiplied and divided by 2. I took Vm, Im outside, Vm and Im here outside, multiplied and divided by 2. Why? Because I want to use compound angle formula. I have this thing with me. I want to convert in this way. I have this thing with me. Then I want to convert in this way. So I have the compound angle formula. Whatever is given is c plus d by 2. Whatever is given here, that is c minus d by 2. Solve it. When you solve it, you will get c value, you will get d value. Is that clear? So that is what 2 into, sorry, I made a mistake here. I should not write 2 here.
Yeah, sir. That's what I'm not understanding.
Okay. I should write here, that will become 2 omega t plus 5. Okay. And so how much is c now? So we got c value. 2c value is equal to, that is 2c is equal to 2 omega t. 2c is equal to 2 omega t plus 5. Okay. So here what will happen? C will become omega t by 2 omega t plus 5 by 2. Okay. Similarly, you can find d also. This will become 5 by 2. Okay. This will become 5. And what is d now? When you solve it for d, substitute this c value somewhere. So what will happen? C minus d is omega t. Sorry, I want d now. I'll take c plus d. C plus d is equal to what? Omega t plus 5. And then c value is omega t plus 5 by 2. 5 by 2 plus d is equal to omega t plus 5. Then we get this and this will go away. D will become 5 by 2. 1 second. Let me see once again. C plus d by 2 is equal to, oh, this here should become 2. Here also it should become 2. I have to cross multiply this now. See here. See, c plus d by 2 is this much. Cross multiply, this 2 will go here. C minus d by 2 is this much. This 2 will go here. Did you understand now?
Yes, sir. But how is D getting
Wait,
cancelled?
I will do it again. So what will happen now? 2c is equal to 4 omega t plus 2 5. Okay. So c will become equal to how much? 2 omega t plus 5. Is that okay?
Yes, sir. Now it is okay.
Now it is okay, right? Now what about d now? Substitute this value in any one of the equation. C plus d is equal to what? 2 omega t plus 2 5. Okay. C is what? 2 omega t plus 5 is equal to 2 plus d equal to 2 omega t plus 2 5. So this and this will go away. D is equal to 5. Is that clear now? I got C value and I got D value.
Yes, sir.
Okay. So I got both the values. Now I am going to substitute back in my given equation. What is my given equation? Here is my equation. So P is equal to what? P is equal to Vm into Im divided by 2. Now I can write cos D minus cos C. Cos D minus cos C. What is C? 2 omega t plus 5. Is that clear now? Is this clear?
Yeah, sir.
Yeah. Now I am taking. So this I am not taking into consideration. Now this is a constant now. P is a power is a. I'm taking here power is equal to Vm into Im divided by 2 into cos phi. Into cos phi. So again, what I'm doing is I'm not taking this part. This again has a angular frequency. So I'm only taking this much part. Okay. For the part.
Why are we ignoring it?
Or why are we ignoring? Here, see here, the power factor means what? I want to calculate the power factor means I want to calculate the power of the circuit. Okay. So I don't want to because only constant values I can take. This is the voltage value, this is the current value. This is also there, but I don't want to take this because this is having the angular frequency component and there are two variables in it. Is that clear?
Okay, sir.
I just want to keep it away to find out a proper value, constant value. Okay.
Yes, sir.
Now, cos phi. So what will happen? Now I am dividing. See, this 2 is split into two parts. 2 is split into root 2 and Im by root 2. Im by root 2. And then cos phi. Okay. So cos phi. What is V? V is Vm by root 2, right? V is Vm by root 2 and I is Im by root 2. Cos phi. Is it clear? V is Vm by root 2, I is Im by root 2. That's the average power. Okay, to calculate the average power. So now we can write P is equal to Vi cos phi, or we can also write P is equal to I square R cos phi, or we can also write P is equal to V square by R cos phi. These are three ways in which we can calculate the power factor now, because we have three formulas for power. P is equal to Vi I square R V square by R. In the place of R, I have taken Z. In the place of R, I have taken Z. So therefore, I got three formulas for power factor. Okay. So average power depends on these values. So these are the average values. Average power. These are the average power depends on P, I, and cos phi. All the three values. So here cos phi is called power factor. Cos phi is power factor. Cos phi is called power factor. Clear? Cos phi is said to be the power factor. Is this clear, all of you?
Yes, sir.
Yeah. Okay. Where is wattless current? Okay, wattless current is here. There are four cases here that we will discuss now. Is this clear, Mr. Abid?
Yes, sir.
Yeah. So what are the three formulas of power? Normal formula.
I square R.
Yeah.
Um,
P is equal to Vi equal to I square R equal to V square by R. Okay.
yes, sir.
Those are the formulas of power. Then, okay. So, and here we have P is equal to, for power factor, there are three formulas. Cos phi is set with the power factor value. Okay. Now, there are four cases we will discuss now. Resistive circuit, pure inductive circuit or capacitive circuit, LCR series circuit, and power dissipated at resonance. These three we will discuss now. These are the four cases in power factor. Okay. Just take one picture. I'll just drink some water. Okay. So we'll discuss the 4 cases now quickly. Then we can start transformers also. Transformers and AC generator. This is little dry. I can understand. First we studied about the resistor circuit, resistor in AC, inductor in AC, and capacitor in AC. After that, we discussed about LCR circuit. In LCR circuit, we discussed 2 cases. Phasor diagram method and analytical solution method. These are the 2 methods we discussed. After that, started the bandwidth, sharpness of the resonance, quality factor. Then we discussed power factor. Then power factor. All these terms we have discussed. This is little dry, and you are doing it for the first time. So it is little difficult. When we do revision also, and when you study, you will become familiar about it. Okay, familiar with the terms, and familiar with the topic also. But it will take some time because it's something new. And I will tell you one more thing. In school also, they will never go in detail with this topic, especially this AC current. There are so many students can ask so many questions. There is a possibility of asking so many questions. And not that teacher doesn't know, but the thing is, it will consume so much of time to explain. Okay. And the teacher has to be limited to the terms only. He should not deviate from the topic. That's the reason. Okay. So that is why in the school, they are very, very specific. They just write the definition, write the formula, finish. In that way, they go ahead. Okay. But did you understand the terms? What is bandwidth? What is sharpness of the resonance? Then what is quality factor? What is the power factor? Did you understand all these terms?
Yes, sir.
Yeah. So still, if you have any doubt,
Sir,
you
can you repeat again what exactly is power factor? How do
Yeah.
we use it? Where do we
How
use
do we
it?
use that? See, first is, what is a bandwidth? Okay, in simple definition, what is bandwidth?
Yeah, yes, sir.
Bandwidth is what? Bandwidth is resonance from the resonance frequency on either of the sides. Okay, how much you can hear the song in simple, or range of available frequencies. That is a simple definition of bandwidth. Okay, the formula is what? 2 delta omega. Omega 2 minus omega 1 is 2 delta omega. And sharpness of the resonance formula is what? It's the ratio of resonance frequency to the bandwidth. In simple words, resonance frequency to the bandwidth is the sharpness of the resonance. How sharp it is. The more the sharp, the more you can you have more availability now. And next one is what? Quality factor. Quality factor is what? Quality factor is about the Q is equal to 1 by omega naught CR, or 1 by omega 0 L by R. Okay, that is about that ratio is known as the quality factor. And now if R is low, or L is if resistance is low and inductor is very high, then what will happen? The selectivity will be more. You have more selectivity. Means you have more options to select. The volume or the control will be more. Okay. Next is power factor. What is power factor? Power factor is nothing but we are calculating the power of the circuit in AC. Power of the circuit in AC. How much is the power of the circuit in AC? Is that clear? In simple words, what is that? VI cos phi. In general, but we solved it. That's a different thing. But in general, what is that? Power is equal to VI. VI, we have the formula. There are 3 formulas. VI, then I square R is equal to V square R. These are the 3 formulas with which we can calculate the power of the circuit. Now you have inductor, capacitor, and resistor in the circuit. You want to find out the total power of the circuit. If you want to find out the total power of the circuit, we have to just multiply voltage, current, and cos phi. What is phi? Phi is the phase between the actual voltage, applied voltage, and the resultant voltage. Is it not? Did you understand?
Yeah.
So that is a power factor. Is it clear? That's a power actually. Cos phi is known as power factor. Is it clear?
Okay, sir.
Got it? Now, so, and also, you got the idea of selectivity. What is selectivity? Okay.
Yeah, sir. So power factor can be positive or negative or
The power
zero.
factor generally is a positive value only, or zero. Is a positive
It
or
can be
zero?
negative also, right?
So cos phi is from negative to positive, right?
Yeah.
From -1 to +1.
Yeah, so it can be negative, positive, and 0.
But we don't get negative value. I will tell you. Suppose if phi is equal to 0, what will be the value? Cos, if suppose phi value is 0, if the angle
Yeah.
between the resultant and this one is 0, then what will happen?
It is
We'll discuss the first case now. Okay, the first case.
okay.
The first case is what? Case 1 is resistive circuit. Case 1 is resistive circuit. Resistive circuit. In resistive circuit, what you're doing now? Here only R. Okay. Resistor circuit means only resistor is working. Means what? Phi is equal to 0. Means what? Cos phi is equal to 1. Is it not? If phi is equal to 0, cos phi is equal to 1. That is what? Maximum power dissipation takes place. Maximum power dissipation takes place. Is it clear? This is the case 1, first case.
Yeah.
The second case 2. We will see that also. In case 2, what will happen? That is purely inductive capacitive circuit. Purely inductive or capacitive circuit. Purely inductive or capacitive circuit. Purely inductive and capacitive circuit. In that case, what is happening? We have only resistor or only L or only R. We have any one of them. The phase difference between current and voltage in both the cases is how much? The phase difference generally is how much? Leading or lagging, whatever it is. How much is that? If it is only inductor or only capacitor in the circuit, what will happen? How much is the phase angle between the applied voltage and the current? In inductor, in inductive
Pi
circuit,
by 2.
pi by 2. Whether it is leading or lagging, that I'm not concerned. How much is the phase difference? The phase difference is pi by 2, right? So what happens?
Yes,
The phase difference between V and I. Phase difference between V and I is how much? Pi by 2. Is that clear? It is equal to pi by 2. So what happens? That means what? Phi is equal to pi by 2. What is cos phi value, madam? Cos phi value is 1. Yeah. This is known as no power dissipation. There is no power dissipation. Okay. This is also known as wattless current. This is also known as wattless current. Is that clear? If he is asking define wattless current, if the phase angle is 0, that is phase angle is 90 degrees, cos phi is equal to 1. That happens in inductive capacitive circuit. No power dissipation is taking place. Such circuit is known as wattless current. I will go back to India now. In India, we have, like we have power meters. We have here also we have power meters. The power meters are there. So, like suppose what you are not there. You are on a vacation for 1 or 2 months out of station, and the person came. That person, the electricity person, he came. He took the reading. Okay. So what he says, okay, that it is showing 0 0. Nothing. You haven't you all the power devices are switched off before you left. Okay, and it is showing 0 0. But when you came back and when you started the like consuming the electricity, after 1 month you got a new bill, but the new bill is too high or too low.